Today, we're going to learn a little bit about mastocytosis. The term mastocytosis itself can be broken down into mast, meaning involvement of human mast cells, and cytosis, meaning a condition in which more than the normal levels of cells are present. Mastocytosis as a disease is a group of disorders caused by higher than normal levels of mast cells either in the skin or in other organ systems in the body. To truly understand why mastocytosis can be such a serious problem, we first must take a closer look at a mast cell. Mast cells are a type of white blood cell that is found in connective tissues all throughout the body, especially under the skin and in the lungs and intestines. Mast cells contain little bundles of chemical messengers called granules. When mast cells are activated, these granules break down and release chemical messengers such as histamine, heparin, and growth factors that can lead to allergic reactions and immune responses. These chemical messengers have many effects, including the typical allergic responses we see, such as watery eyes and runny nose, tightening of the airways, as well as widening of the blood vessels, leading to inflammation. In a person with typical levels of mast cells, mast cell activation may lead to mild symptoms that we typically associate with the allergic response, such as runny eyes and runny nose. Mastocytosis, however, occurs when there are too many cells produced at the body at specific body sites. The overproduced mast cells are activated more frequently than regular mast cells and cause more severe symptoms as a result of the increased levels of chemical messengers through increased mast cell activation. In mastocytosis as well, mast cells can also be activated in the absence of environmental triggers, which can worsen mild symptoms such as excessive flushing and itchiness, and lead to more severe symptoms such as organ dysfunction, anaphylaxis, and even death. Mastocytosis can be broken down into two broad categories, cutaneous and systemic mastocytosis. Cutaneous mastocytosis occurs when there are increased mast cells in the skin alone, leading to redness, itchiness, and scaly skin. This type of mastocytosis is more common, is much less severe, and is typically seen in children. Systemic mastocytosis, on the other hand, is different from cutaneous as it often involves parts of the body like the spleen, the liver, the intestines, the lungs, the bone marrow, and may or may not also have skin involvement as well. Systemic mastocytosis is much more severe, and people who have this form have decreased life expectancy, can be more likely to have severe allergic reactions, can be more likely to have osteoporosis and other health-related complications, and they also have a greatly reduced quality of life due to their symptoms. There are a few known things that scientists have proven can be used as red flags for developing symptoms of mastocytosis. One thing that is known to cause for excessive mast cells to be produced by the body is a mutation in the genetic code of a receptor on mast cells called the c-KIT receptor. These receptors play an important role in allowing mast cells to continue to grow, as well as promoting further mast cells to be produced. While normally this receptor needs a chemical partner called stem cell factor to become activated and produce more mast cells, the genetic mutation in this receptor allows for the receptor to be activated without its chemical partner present. In other words, the mutation causes the mast cell to be continuously activated, and the cell itself does not have a way to inhibit or stop the activation of the receptor. This mutation is typically seen in more severe forms of mastocytosis, such as systemic mastocytosis, and leads to higher levels of mast cells and higher levels of circulating mast cell products, leading to symptoms. Due to the increased levels of mast cells in mastocytosis, the levels of chemicals released by the mast cells in the body is also drastically increased. One of these in particular that leads to many of the symptoms of mastocytosis is increased levels of histamine. Activation of histamine receptors on the skin cells lead to vasodilation, while activation of histamine receptors on the lung smooth muscle cells can lead to bronchoconstriction or tightening of the airways. Since people with high levels of mast cells will also have more histamine, this leads to more inflammation and more symptoms as well. Similarly, another chemical messenger that is made by mast cells is something called IL-6. When white blood cells are being told what type of white blood cell to turn into, IL-6 is a messenger made by the body that causes for more mast cells to be made. IL-6 can be thought of as a middleman in mast cell production, since it's created by mast cells and then also causes for more mast cells to be made in the same way. IL-6 production acts as a positive feedback mechanism, leading to more mast cell growth and production, and thus more symptoms as well. New ways to determine the severity of mastocytosis are at the forefront of mastocytosis research today. In more severe forms of the disease, mast cells that have different shape from normal mast cells can be found in the bone marrow. Our group proposes that by taking a small sample of bone marrow and quantifying the amount of abnormal mast cells that are present in the sample, we would be able to correlate the severity of the disease with the number of mast cells that are present. In other words, the higher the amount of mast cells with abnormal shape, the more severe the mastocytosis and the more severe the symptoms. From our investigation of mastocytosis, two other chemical messengers that are a result of mast cell activation could be used as potential markers for severity of the disease. TNF-alpha is what's known as a cytokine and is a mediator of inflammatory and immune functions. Similarly, IL-33 also plays an important role in the inflammatory response in the body. Neither of these chemical messengers are established biomarkers for severity of mastocytosis yet. In order to determine the amount of each of these cytokines, scientists would perform an ELISA assay, which is a tool used in immunology to quantify the amount of proteins, antibodies, and hormones present, and see if there's a correlation between severity of the disease and presence of these chemical messengers. Since more severe mastocytosis would lead to higher levels of mast cells and higher levels of products from mast cell activation, we propose that both of these chemical messengers would correlate with the severity of the disease. In summary, mastocytosis is a disease which leads to chronically high levels of mast cells and high levels of mast cell activation. One factor in the majority of systemic mastocytosis is the mutation in the c-KIT receptor, which is a red flag for mastocytosis and leads to increased growth and increased mast cell formation. Having increased mast cells leads to increased levels of breakdown products from their activation, and of these products, histamine and IL-6 are proven chemical messengers that lead to the symptoms of mastocytosis. We have also looked at new ways to potentially monitor the severity of the disease by quantifying the amount of mast cells in the bone marrow and also looking at inflammatory cytokines TNF-alpha and IL-33, which could act as biomarkers for severity, as higher levels would likely correlate with the severity of the disease. Thanks for watching.